Okay, very good evening all students. Thank you very much for coming for the business class. So we will continue with chapter 2. Couldn't get the class down because a lot of lecturers are facing class. So thank God I booked you all for the whole history. So we are going to actually study about the assembly program now. All of you have already been exposed to the assembly program during tutorial, but maybe you have not understood why the structure is such. In the tutorial, you were just advised to actually copy paste the program start template, and then whatever code instruction sequence that you write, you're just supposed to copy and paste. So that is for you to just have a hands-on experience on how MPLAB is being used. But now we're going to go in detail to study what are the different components of an assembly program. Now, as I mentioned earlier, there's a difference between assembly program and also assembly instructions, instruction sequence. What you all did previously was instruction sequence, not a program. So we're going to see what do we mean by assembly program. So when we take an assembly program, there are actually three components in an assembly program, and they are the assembly directives, assembly language instruction, and also commands. You don't have to memorize all these things. This one, no one's going to ask you in tests or in finals something. This is for you to understand what is assembly program. So I'm going to use MPLAB to show you. Actually, I'm trying to use the mic somehow or other.
It's working.
Hello. Yeah. Can hear? Yeah. Really? Hello.
This one is working.
Hello. Loud? Can you hear? I'm hearing my own voice. Hello. Oh, can you hear? Now I can sit here peacefully. Hello. Can everyone hear?
Sir, it's jumping.
What, jumping? Oh, wait. I just see. So I'll try to explain this assembly language program. Okay, now the screen is white. So as I mentioned earlier, the components of an assembly language program consist of assembly directives, assembly language instruction, and also commands. So let us look at one example program. We have actually seen this program before, right? Now this whole thing is what we call as assembly language program. Now just now it mentions three components, right? Assembly directives, assembly language instruction, and also commands. Now all these three are actually here. So for example, commands is actually this one. Is it large enough? Can you see it now? So this green one, you see the semicolon? Anything after semicolon becomes a command. And you can see that the color is green. Can you see the color green there?
Yes.
So that is command. So in an assembly language program, you have a component which is command. If you want to leave any command, you just have to use semicolon. Like for example, this one, I put semicolon main program to indicate that after this is main program. So that is command. And then you have assembly language instructions, right? Can you identify which is assembly language instructions? All this, move LW, move FF, they are assembly language instructions, right? Guys? Yes. So two of the components of the program has been covered. So the last one is actually assembly directive. Now assembly directive is, for example, what is actually assembly directives? Assembly directives are certain set of commands, or let's say like a keyword, which is used in the program to indicate how should a program behave. For example, this hash include is actually an assembler directive. What it does, it includes this file as part of this program. Another example of course, we will learn in detail about the assembler directives, but from the name is actually assembler directives. It directs how the assembler program is supposed to work. So for example, this hash include is actually an assembler directive. What it does, it includes the memory mapping of all the special function registers and all the registers which is in this model PIC 18F458. There's another assembler directive which is ORG. ORG means origin. Origin hex 00 and then you have go to start. So what it means that origin hex 00 means anything you write after this, this go to is actually an instruction. It's under control. We have not seen the control instruction format yet, right? Remember there are 5 types of instruction category: byte to byte, bit, literal, control. Remember we didn't cover control. So go to is actually a control oriented operation. So when you write origin hex 00 and then after that origin line, if you write any instruction, what it does is this instruction will be stored at this address. That's what it actually means. Origin is actually assembler directives. It's one of the assembler directives. What it does is the subsequent line, which is go to start, right? This go to start is actually an instruction. This instruction will be stored at this address. That's what it means. So it actually directs the next instruction to be stored at which location. Same goes with this one, RETFIE. This is also an instruction. Where is this instruction stored? Yes, at address hex 08. Of course, you may ask this question. This hex 08 is in which memory? Is it data memory? Is it access bank? Or is it program memory?
Program.
It is program memory because we are doing program. So then you may ask this question, well, why only got 2 hex digit? Actually got 6, but in front, the zeros in front actually doesn't matter. The zeros after a digit matters. So you understand? So here I cannot just write hex. Of course I can write hex 8 also, which means hex 8. So it means that this address is actually 000008. So it means, but you don't need to write all the 6 address because in front the 0 doesn't make much difference. So what I'm trying to show here is assembler directive. These are some of the examples of assembler directives, origin. And then you have another assembler directive, this one, END, end. What do you think this assembler directive will do? It will indicate that's the end of the program. So if your PC comes to end, it will automatically disappear. If you notice, in our previous example, if you try to press F7, it will go down. When it comes to end, it will disappear, right? So that is assembler. So how many components are there in assembly language program? There are 3. You have assembler directives. Some of the examples like END. Of course, as we go along, you will learn origin, hash include. There are some of the assembler directives. And you have assembly language instructions like move LB, move FF, and you have commands. How do you command? By using semicolon. Any question up to this point?
So
Yes.
the third component is comments itself only.
Come again?
The third components in program comments is one of it.
Yeah, the third component is command.
So the origin hex can be changed, or must it follow hex 00, hex 08?
Hold on. You mean the starting one?
Yes,
This one you have. This is fixed.
it's fixed.
This whole part here is fixed. You cannot change the one. Of course, later on in chapter 6, we'll make some modifications here and also here. But until chapter 6, this whole portion, do not change anything. Okay? Any other questions? So let's go back to the slide. So those are the three components of the assembly language program. Now let us see the elements of an assembly language statement. Just now we studied the overall program. Now we're going to see statement. What do we mean by assembly language statement? Assembly language statement means one line. In that one line, we can actually have four elements. They are label, they are mnemonics, they are operands, and they are comments. So let us see. Now just now we saw the whole program, right? This whole thing is a whole program. The next one we say is assembly language statement. Statement means this one line. This whole one line.
Sir, it's not changing.
Oh. Thank you. So just now we saw the overall program. The overall program has three components. Okay. Now we're going to see in one assembly language statement. So I have highlighted this whole one line is known as assembly language statement. Every line is actually a statement. So what the notes were actually telling, in one statement, you can have up to maximum 4 elements. You can have maximum 4 elements. So it says the first one is label. See, this is label. The second component is actually the mnemonics. What is mnemonics? Mnemonics is actually a representative of the opcode, right? So mnemonics is this, move LB. They are the mnemonics. They are numerical representation. And then you have the operands, which is this one. This operand could either be literal value or it could, most of the time it will be address. And then, of course, here we don't have the fourth one. And then you can have comment. So at most in one whole line, in one statement, you can only have 4 elements. So what are those? You can have a label, you can have a mnemonic, you can have a operand, and you can have comments. So this is what we call as assembly language statement. One statement can have maximum 4. There cannot be more than 4 elements. Minimum, you must have at least 1. Usually it will be the mnemonics. Like for example, if you type like this, NOP, no operation, right? This is also a statement, but you only have only the mnemonics. Is that okay? Any questions so far? So let us now go into each. We are zooming into the assembly language statement. So we're going to see what are the criteria for the label, mnemonics, operand, and also comments. So the label field. Now don't worry about how do we use that. Just understand where the position is and where the label can be, where the mnemonic should be, and where the operand and where the comment should be. So there's one more thing I forgot to mention. That just now we saw this, right? the label field, if you take this one statement, the label field must be starting, assuming that you break this down into columns. Assuming you break one statement into columns, so that means you'll have one column, second column, third column, and fourth column. Are you all following? 4 elements. Let's say one column for every element. So in the first element, the label field must always start at the first column. Must. The label must start from the first column. You cannot actually leave space for a tab. And then the second column must be mnemonics, and the third column must be operands, and the fourth column must be comment. So if you want to, you cannot start like this. Of course, I think you will just get a warning, you won't have an error. So you shouldn't start like this, because it will assume that this move LB as a label. So if you don't want this to be assigned as a label, at least you give a space. How does the compiler know the difference between the first column, second column, third and the fourth? The first, second, third and fourth is actually separated by at least a space bar. The first column and second column must be at least separated by a space. And of course the comment, as long as you write semicolon, it's okay. So let us see the label field, the conditions for the label field. So the label field must start from column 1 and followed by a tab. As I mentioned earlier, the label field must start from column 1 and followed by a tab, a space, a colon, or the end of line. A tab means you give a tab, a space means the space bar, a colon, this is not a semicolon, colon, or the end of line. End of line means enter. When you enter, that separates the label column. And the label field must start with alphabetic character or underscore. Alphabetic is not alphanumeric. Huh? Alphabetic means A to Z. Or you can start with underscore. May contain alphanumeric characters. That means in between you can have characters like 7, 6 and things like that. Underscores and question mark. These are the only allowable characters. May contain up to 32 characters and is case sensitive by default. So if you see here, can't see. This is getting a bit hassle each time you need to make it private. So as you can see, the start, either you can start with underscore, or you can start with this. You cannot start with number. You see it changes into red. So you must start with alphanumeric, but in between you can put values, no problem. You can also have question mark. But do you see when you put the open bracket, close bracket, the close bracket color is a bit different from, it's not recognized. So not all characters are allowed, only few characters are allowed. So those are the criteria for the label. Any question up to this point?
So, if you press tab twice, does it mean that the thing that the mnemonics is shift into another column?
No. No. So your friend was asking, if like this, if I tap twice, does it mean that the move LB goes into the operand column? No. It doesn't work that way. How it actually differentiates between the label and also this one is minimum space. You can tap how much you want also, it's not a problem. But the compiler knows that if there is a gap, there is a tab or a space between the start and move LB, and the start is starting from the most left hand side margin, it knows that the start is a label. And then after the space, it will check what is next. Oh, it is move LB. So move LB have to be mnemonic. After the mnemonic, after the space, what the compiler will see? 2. This 2 is actually the operand. And actually the compiler ignores this. The compiler doesn't take into consideration of comment actually. Whenever it sees the semicolon, after that it ignores. It doesn't compile. It doesn't get what do I mean by ignored is you don't see these comments stored in your program memory. It is just for us to view. So as long as the compiler sees semicolon, it won't do anything. But this one, the start, the move LB2, all these things will be, especially this move LB2 will be stored in the program. So if you don't give a space, it will assume that, see, now I don't leave a space. Do you see the move LB also changes color, becomes purple? It's a bit small. So at least minimum we need one tab. Then you see the move LB changes color, becomes blue. Because blue is actually for mnemonic. Is that okay? Any other question? Yes?
The label is actually user-defined or predefined?
It's user-defined. We actually define.
So any names can be used?
Yes, any name can be used, but it must be in path. So let me just since you asked the question, okay, do you see that there's actually start here and also start here? The start is actually the label, and the label must be in pairs. So just to illustrate what is actually happening here is, now this origin hex 00 is an assembly directive. What it means that the line after origin, that particular instruction is stored at this address hex 00. Now, do you remember in chapter 1, the address 0 or 000000 has another name. What is it referred as? What? Someone say something? It's not clear. What is it referred as? Yes, it is known as reset vector, right? Now, what happened is, do you
So example, if let's say you got
sorry for that. So what it means that at address 00, at the program memory address 00, this go to start is actually stored. So go to start. Go to is actually the control instruction. It says go to the label start. Where is the label start? Here, right? So that's why if you see, let me see, compile this.
error. Oh, not responding, error.
Okay, see, Do you notice that the green arrow is actually pointing at go to start and not at origin hex 00?
Yes.
That is because origin hex 00 is an assembly directive. It controls how your program is. It is not an instruction. If you see in your program memory, you don't find the origin 00 there. It is not a code. It just indicates that the instruction go to start is stored at address 00. So now what happened is, when you press F7, where do you think the arrow will go?
Start.
Why is it going to start? Because we are using the label start.
Pointing to start.
So if you put the label another place, say you remove here, and you put it somewhere here. Okay, make it. You press F7. Do you see where it goes? It goes to the place where the label start is. Get it? Any other question? Of course, it is case sensitive. So if you put a small letter here, the other side also, it is a pair. The label is actually a pair. So later we'll see how the label is being used. So for now, do you understand? The label must start with the first column. That's why during tutorial also I told that make sure you type the code in the proper indentation. One thing, of course, it looks neat. Another one, it actually differentiates between the label field, the mnemonic, the opcode, and of course the command. So when you actually cultivate such a habit of writing program, it looks neat, and whenever you want to troubleshoot, it becomes easier. Any other question?
So if let's say one line got two mnemonics, how ah?
One line got two mnemonics. It's impossible. Never have two mnemonics.
So that means let's say the move VLB, we bring the move FF up.
If you put another move FF here,
No, I mean let's say the move VLB 2, then later move FF at the same line.
here,
Yes.
you'll have error.
Missing operator. No operator.
Symbol not previously defined. It says a symbol not previously defined because the assembler takes it sees by the space. So here got space, there's no label, okay, ignore, there's no label. But then this move LB is not starting from the left margin. So it assumes that there is no label. So straight away it checks what is next. Oh, let's move LB. So this is the mnemonic. After mnemonic is supposed to be opcode. But then after that, again you put move FF. So it says symbol not, it says that it's not recognized. Even though move FF is actually a valid instruction, but it is not recognized by it because after the operand, it is not supposed to take in another mnemonic. So that's why it says the symbol not found, or what was the error just now? The symbol not defined. This one. So that's what will happen. Any other question?
So in the end, can I copy and paste already lah?
So let us go to the mnemonic field now. Very quickly, we'll try to cover as much as we can. So the mnemonic field, which is this is actually the second column. So the mnemonic field can be assembly language assembly instruction mnemonic. As I mentioned earlier, it can be assembly language mnemonic. For example, move LB, move FF. Those are assembly language mnemonics. Or assembly directive. So for example, we saw at the second column, we have seen assembly directives like ORG, like origin. We also have seen assembly directive like E and D. So in the second column, we can either have the assembly instructions or we can have the assembly directive. So it must begin in column 2 or greater. That means how does the compiler knows that it is in column 2? Minimum one space from the most left margin. So as long as you space, it won't consider that as a label. It will consider that as a mnemonic. and it must be separated from the label by a colon, one or more spaces or tabs. So I have already showed that before. Any question on that? And after the mnemonic field is actually the operand field. The operands. Now operands, as I mentioned, is actually the field where you have the F, B, A or the K. Those are actually the operands. So as you have seen so far, the example that we have done, in the operand part, we have actually used to load a literal value, or we have used to identify the address of the file register that we want to manipulate or we want to use. So the operand field follows the instruction mnemonic, because that is actually the format in your instruction set as well. And it provides the operands for an instruction or arguments for assembler directive. So operands for an instruction means, for example, move LB is actually the mnemonic, and just now we wrote 2. 2 is actually the operand for the move LB, right? Operand means the value that you want to load, or you can call it as argument, or argument for an assembler directive. When you say argument, is not fighting argument, it's a value or variable. So arguments for an assembler directive means, for example, just now we saw one assembler directive, origin. Origin is actually the second column. After origin we saw hex 00, right? That hex 00 is an argument for the assembler directive. What do you mean by argument is as an input. It tells that the next line should start from this address, hex 00. So the hex 00 is not something for it to manipulate or things like that. It is an input for the assembler directive to indicate that the next line will be stored at address 00. Is it okay? Any question up to this point? And it must be separated from the mnemonic field by at least one or more spaces or tab. So the minimum requirement is from each field is you must at least have one tab. So take note of all this, because we are having quiz, right, this Thursday. So multiple operands are separated by commas. For example, move FF. Can you see my mouse pointer? All this while I was thinking I was showing my mouse pointer. I hate problems. This one. So if you have more than one operands, you should separate them by commas. Now in the instruction set also, we have seen before, like for example, add WF, you have F, D and A. Those are 3 operands, right? So those 3 operands are separated by commas. The comment field. The comment field is actually optional. The comment start with semicolon, so that the most important one is actually the semicolon part. Because some of you earlier had made the mistake during our tutorial by putting the semicolon before your instruction, so it will treat that as a comment. So all the characters to the right of the semicolon are ignored by the assembler, as I mentioned earlier. The comments provide documentation to the instruction or assembler directives. So a comment may explain the function of a single statement or the function of a group of instruction. So writing comment is actually one very important documentation. Many people they feel lazy of writing comment because they find it consumes too much of time. But in actual reality, it actually helps you to understand the code. It's very, very important for you to do documentation. So documentation, you can Either you can write comment line by line. Okay. Either you can write comment line by line, or you can use block comment. Block comment means, let's say this whole, you have seen this instruction before, right? Have you seen this before? This is your tutorial question number 1. So instead of writing the first column here, okay, moving the content of hex 200 to working register, then you put another comment here, moving the content of 201 to hex 200, and then you put another comment here, moving the content of working register to file register at hex 201. Is it a good comment? Yes. You are explaining, but do you get the picture? It will be easier if you just put one comment here, swap the content of hex 200 with 201. That is known as block comment. Certain things you can actually comment line by line. For example, this move LB2, this requires a single line comment, which is activate bank 2. For the rest, you don't need to put line by line. Of course you can, you will understand what each is going on, what each thing is doing, but it will be easier if you do block comment. So you can write does this make much better comment? So this is known as block comment. That means you take one whole block, you just comment the whole thing, what the whole block does. Is it okay? Any question up to this point? We will know all that during this Thursday. So the next thing that we're going to see is the assembly directives. So earlier I did mention that the first slide we saw that on the components of an assembly language program, it consists of assembly directive, language instruction and commands. Now we took this assembly language statement and we saw what are the 4 elements that we can have in one line. In one statement, what are the 4 elements? And we have seen the criteria for each one of these. And we have seen what comments are for as well. So language instruction is actually reflected in the assembly language statement. The last one which is left is actually the assembly directives. So now we're going to see the types of assembly directives which are available. Can you all see this one? Can you all see? I prefer to do like this, because if I keep changing, it becomes difficult. So now we are on the topic of assembly directives. As I mentioned earlier, assembly directive controls the flow of your program. So there are a few types of assembly directives. There are control directives, data directives, listing, macro, and also object file directives. Now you don't need to memorize all this, but you need to know how to use them. So you will learn, so don't worry. So let us see the first one, which is control directives. So for example, one example of control directives is if-else statement. This is actually the syntax. This whole thing that you see here. This, if you want to use this control directive, you have to have this format. If, you need to give an expression, then you write whatever statement, else, and then end if. So here for example, it's mentioned that if the version is equal to 100, then you execute this one, else you execute this one, then end if. So let's see if we can do this. I think I've done this before. Try and find. Chapter 2. a lot of things I can face. Just give me a minute. Okay, this is the example. Okay, this is the example of the control directive. Is using the if-else statement. Just now we saw that I have a lot of errors because this if-else statement I actually started from when I copy-pasted it. It actually pastes in the most left-hand side. So it will consider the word if, else, and end if as label. So therefore, it will actually cause it to become error. So you need to tap it because this is a control directive. Remember in the mnemonic field, just now we saw, in the second column either it can be mnemonic field or what is the second one? Just now we saw in the mnemonic field, when we saw the slide right, it says the mnemonic field should start from column 2. So in column 2 you can either have the assembly instruction mnemonic or what? Yes, assembly directives. So because this if, else, and if they are assembly directives, they should start from column 2. And just now I have error here also because when I copy paste from the slide, the single code is not this single code. So therefore it will cause error. So what I have done here is I have declared one variable. EQU means equal. So of course this is EQU also is another assembly directive we will learn later. But for now I'm just showing you I have created one variable by the name of version is actually equals to decimal 100. Why? Because let's see if version is actually equals to 100, it will actually move to this. Else it will actually execute this set of instruction. Now my question is, here is actually mentioned equals to 100. Is this decimal 100 or hex 100?
Decimal 100.
How many says it's decimal 100? The rest saying it's hex 100. Anda pasti rin jawapan Anda? So let's find out. Let's find out. So I'm going to compile this. So we are here. Press. It actually went here. Okay, let's add something so that you can see. I just put a no operation here. So I have reset this one. So it's now is in go to start. When I press F7, it goes to NOP. No operation. Why I just put the NOP? Otherwise it will straight away execute this one. So just now who said that the version is actually equals to decimal 100? Okay, if it's equals to decimal 100, it will actually execute this one. If it's not, it will execute this one. 1, 2, 4. So what it means? It means that the 100 is hex. If you don't put a prefix, it will consider it as hex. So let us try to change this one as hex 100. Okay, so we are back here. Press F7. Do you think it will go here? Yes. Why? Because the version is equals to hex 100. We have declared it here. So this is the example of using the if else and if. So this is the format. You must have if, you must have else, you must have and if, and then you must give an expression here. This must be some condition. Something equal to something mean you do this, otherwise you do this. Of course you may ask, what does this one do? This is just some dummy instruction. Just move literal value into working register and move the content of working register to hex 10. Else you do this. What I want you to understand is the usage of this if else. Is it okay? Any question up to this point? Yes or no? So another lesson that we learn is anything that you don't put prefix here, we will consider this as hex.
So we basically don't need to write the US function.
We'll try to take another one example then. Okay, this is the first control directive that we learned, the if else. The second one is end. We've already seen that. The end indicates the end of program. It's quite simple. So it controls. Why call it as control directive? It controls the flow of the program. Just now you saw the if else. It controls the pointer where you should go. Same like end. End means it's the end of the program. We don't use this define, so it's key. This one also I mentioned earlier, include, hash include. This is also under control directive. What it does, what it controls? It controls the memory. It actually includes the file. And then the last one is radix. It sets the default. I think there's no question. Is there any question on the include? It's quite fixed, right? Any model that you use, you have to include that model name. For example, PIC 18 here, there's 8680. That means that's a model. So in class, we are actually using PIC 18F458. So we just write P18F458.inc. So that's the file that we use. So the last one example that we take for tonight is radix. Now what is radix? Radix actually sets the default radix for data expression. The default radix values are hex, decimal or octal. So just now I mentioned that right here. Just now I mentioned that any data or values that you write without the prefix, you know what's prefix, right? The hex, 0x, that prefix. That value will be considered by default as hex. So for example, the earlier one I did, when I actually put this as decimal 10. But is this decimal 10?
No.
I mean, sorry, decimal 100?
No.
No, it is actually hex. But what if you can you want all the values without prefix to be the same radix. Radix means the same base number. So you can actually use radix decimal, for example. Take note that I am starting from the second column because radix is an assembly directive. Radix decimal means any number that is without a prefix will be categorized as this base number. So let's build this. Do you see? Now it actually goes here, right? Earlier, if I make this as comment, radix as comment, and if I execute this back, see, it goes to the next. That means, by default, if I don't put any prefix, it considers as hex. But if I use radix, what radix does is, any number that is without a prefix will be that radix. So in this case, this 100 is without prefix, right? So this will be decimal. Of course, if you put prefix here, if you put prefix like this, the prefix will override the radix command. That means if you put prefix, the number is hex. The thing is, if you don't put prefix, so if you don't put prefix, it will belong in decimal category. So if you do this, see, you can actually read. So that is radix. Is it okay? So far we'll actually just stop here. We'll learn, we'll continue about more of the assembly directives tomorrow. There's no question. Thank you very much for coming. I'll see you all tomorrow morning.